2019 Impacts and Collisions, question 5a. A small smooth sphere, A, of mass 3m, moving with speed u, collides directly with a small smooth sphere, B, of mass m, with speed u in the opposite direction. So be careful with this speed here, it's the opposite direction, minus u. The coefficient of restitution between the spheres is a half. So if we start with the principle of conservation of linear momentum, we'll call it PCM from now on. M1, U1, plus M2, U2 is equal to M1, V1 plus M2, V2. So we have 3M, they're both traveling at U, so 3MU plus M times minus U is equal to 3M V1 plus M V2. So that's, we can divide across by M, and we're going to get 3U minus U, 2U is equal to 3V1 plus V2. Now we have Newton's experimental law of restitution, which will bring in this 1 over 2, my E. And Newton's experimental law is V1 minus V2 over U1 minus U2 is equal to minus E. So we can also write this as V1 minus V2 is equal to minus E times U1 minus U2. So we fill our information in. V1 minus V2 we're looking for equals minus a half by, they were both U, so one was U and one was minus U, so U minus minus U is going to give me U plus U. So we're going to get 2V1 minus 2V2 is equal to minus 2U. I'm going to divide across by 2 here. V1 minus V2 is equal to minus U. So we bring this line down, we can get rid of our V2s. We're going to end up with 3 V1 plus V2 is equal to 2U. So we're going to get 4 V1 is equal to U, which would leave V1 being U over 4, or a quarter of U. Now, what can we simplify this into? It doesn't really matter which one we use. Let's use this one here. V1 minus V2 is equal to minus U. So we have U over 4 minus V2 is equal to minus U. So minus V2 is equal to, well, a whole U, and then we're taking away a quarter, so minus 5U over 4 minus 1 and a quarter. So just change the signs here. V2 is 5U over 4. So that's part 1. Part B of this question. After the collision, B hits a smooth vertical wall which is perpendicular to the motion of B. The coefficient of restitution between B and the wall is 2 over 5. The first collision happens when the spheres are 2 meters from the wall, or 2 meters from the wall. The spheres collide again 4 seconds after the first collision between them. Find the value of U. Okay, a little diagram might help here. 2 spheres collide, A and B. B then goes in this direction towards a wall which is 2 meters away from the collision. So as B is traveling towards that wall, A is continuing to move. So when B hits the wall and rebounds, A will be a particular distance away from B. So let's look at the information that we have for B to begin with. We have a speed, 5U over 4 with V2. So B is traveling at a speed of 5U over 4. The distance to the wall, that's speed. We also have distance, which is 2. So we can get the time. We know the time with your DST triangle. Time is distance over speed, which is equal to 2 divided by 5U over 4, or multiplied by 4 over 5U. So the time is 8 over 5U. So that's the time it takes B to get to the wall in terms of U. Now we can use that to find out how far A moves in that time. What's A going to do? A, its speed was V1 U over 4. So speed for A is U over 4, and the time it travels in that interval, the time it travels is going to be 8 over 5U. So we need the distance. that it travels. Okay, distance is speed by time. So speed by time. So we have u over 4 times 8 over 5u. So we can see here the u's will cancel, and we're going to get 8 into 4 goes twice. So 2 over 5. So that'll be 40 centimeters. 2 over 5. So now they're going to be 1.6 meters away. Now I have B here, A here, and there's 1.6 meters between them. And I have a new speed for B. The coefficient of restitution we can see here was 2 over 5. So B was traveling at, his speed was 5u over 4. So 5u over 4 is going to be slowed down by a factor of 2 over 5. So we're left with, that's a lesson in turning your phone off while you're working. So what do we end up with here? U over 2 for B's rebound speed. So now we have B going in this direction at a speed of u over 2. And we have A going in this direction at a speed of, what do we get for A's speed? U over 4. U over 4. So we can combine these speeds, and we're looking for time that they're obviously colliding here, say at the same time. So we'll get one equation for time, and we should be able to find what u is. So speed by time is equal to distance. So we have for A, u over 4 by t, plus for B, u over 2 times t is equal to the distance, which is now 1.6. So we have a quarter of t and a half of t. Well, that's 3/4 of t. So 3t over 4 is equal to 1.6. And they have given us more information for time. They collide again 4 seconds after the first collision. So 4 seconds after the first collision. And B has taken up some of that 4 seconds, this much of it. So the time left is 4 minus this guy here, 8 over 5u. So 3 over 4 times 4 minus, what was it, 8 over 5u is equal to 1.6. So this should simplify down to give me u. So we have 3/4 of 4. Sorry, I left out a u there, didn't I? 3/4 of u, ut. So we have 3u times 4 over 4, which is just 3u, minus 3u over 4 times 8 over 5u. My u will cancel. My 4 divides into my 8 twice, so I'm left with 6 over 5. So 3u minus 1.2, 6 over 5, is equal to 1.6. So 3u is equal to 2.8. So u is going to be 3 into 2.8, which is 0.9, and then 3 repeating. So u is 0.933 meters per second.